Hello, and welcome to this investigation of BioInteractive simulations as asynchronous guided inquiry. My name is Stephen Rogg, and if you're interested, my brief bio is attached as a comment. Otherwise, let's go ahead and get started. Let's consider that indoor laboratories and outdoor field stations exist for important reasons, and I will never argue against the pedagogical value of what I like to call phenomenon-based, hands-on, minds-on, act-on science learning opportunities. However, responses to the global pandemic substantially limits instructional opportunities for direct investigation of natural phenomena. Besides, not all learning is mediated this way, even when well-resourced lab facilities and field sites are readily available. Safety concerns, for example, provide obvious reasons in any natural science discipline to avoid certain experiences. Likewise, concepts such as sampling distribution and statistics are not directly observable and must be modeled. In this case, interactive simulations can function for an instructor as a sort of guided modeling, supporting inquiry that is otherwise infeasible, unsafe, or impossible. In this session, we examine the pedagogical potential of interactive simulations implemented as what I would call asynchronous guided inquiry and personalized learning. So a word about our itinerary. This session considers asynchronous guided inquiry and personalized learning. But as the session itself is asynchronous, it would seem internally consistent to offer it as guided inquiry with attributes of personalized learning for participants. In other words, the session design attempts to model the same pedagogical process we've already examined. Have we entered the matrix? So we begin with a common reference on how our students engage in learning by means of guided inquiry. We should think about the possibility of asynchronous guided inquiry. What are its characteristic features? What does the instructor do? How does the student engage and learn? And what is the quality of that learning? In addition, we might consider why we do labs in the first place and how we might achieve these goals in asynchronous online instruction. I hope this sounds to you like an adventure worth having. Remember that in VoiceThread, you can add your ideas and questions and comments. That's the whole point of this. So you are welcome to do so generously. Although now 20 years aged, like fine wine, and focused on K-12 education, I propose that this NRC report remains a clear, valid, and useful guide. Consider for a few moments if you agree with these essential features. Is this new to you or old news? Do you feel like there is anything lacking? Please feel free to post comments. So I've always enjoyed this tool. It takes the 5 essential features that you see earlier, and it expands them on a continuum from student self-directed and open inquiry to very teacher-directed or material-directed on the other side. I think guided inquiry, the point here is that it just falls somewhere within this continuum. At this point, you may already have strong ideas about the instructional goals you have for lab experiences and how to structure student experience to achieve those goals. Or it's possible you might want to explore further. So I offer this short list, all of which are freely available. Feel free to explore one or more of them now if you are ready, or make comments. You can make additional suggestions or ask questions again. That's the whole point of the session. Okay, so let's connect our thinking about AGI with features of personalized learning. Consider, for example, that the typical lab session, students are together in the same time, in the same place, doing pretty much the same thing in the same way. You get the idea. So we can consider that asynchronous learning can have some advantages. There's no need, for example, to interrupt work because a period ends. Students can proceed at their own pace. I'm reminded of Professor Sam Postlewaite's pioneering modified mastery biology and zoology courses at Purdue University, in which the labs were tutorial and the facilities were staffed and open throughout the day for students to drop in as needed. We can think of creative ideas to be flexible in how we use time, place, and method. And I think asynchronous gives us, an incentive to do so at this time. Once again, I welcome your comments. So this is from Education Week's working definition for personalized learning. The attributes are very nice and useful, very helpful. Um, and just as a starting point, I wanted to point out that I think asynchronous keys in on two of these pillars quite nicely. Flexible learning environments, as you just mentioned, but also personal learning paths. So these I think are the two main attributes that we should keep in mind during our investigation today. So as we did for inquiry, if you are personally interested in going deeper on personalized learning, see what I did there, I suggest starting with one or more of these freely available resources. So we've reached the main question of our investigation. As we interrogate this exemplar, please keep in mind the ideas you have formed about labs as inquiry and how to capitalize on asynchronous settings to foster personalized teaching. So if you're able, this will be a good time to go to the resource at BioInteractive. So the link is on the right-hand side of the screen at the little link icon. Just click on that. Everything that an instructor needs is here. So you see I pointed them out with the teal arrows up on the upper right-hand side of the materials to download. Notice also there's Google folder. So this is kind of a new, but the student work has been converted to a Google Doc, which you can make a copy. And it works great with Google Classroom. And I've also assigned this version on Schoology. So be sure also to click at the bottom of the page. You'll see the show more for a full description of the resource. So we'll launch the interactive and take a look. But feel free to go there and spend as much time as you need because we're asynchronous on exploring that, the entry into this resource. You probably noticed, but there are two simulation models here, really. The first, shown in the screenshot, is the sampling from a normally distributed population. So a button shown in the red oval switches to the other engine. That's the standard error of the mean. Okay? So it helps to understand the difference. The first model allows you to run single random sampling trials while varying the sample size and population parameters. I say that again, population parameters, mean and population standard deviation. Of course, in the real world, we do not make choices. Well, we do make choices about sample size, but we don't manipulate population parameters. So they exist. My experience with high school and graduate school students is that they may struggle to understand that the sample statistics for central tendency, mean, median, mode, and dispersion, such as standard deviation, are estimates. Okay, so the sample statistics are estimates of population parameters. That, of course, is the important key idea. So it's fun to see the influence of sample size and how sample mean varies around the simulated population mean. This reinforces probabilistic thinking. So the first part of the student activity is an investigation of these things. The second simulation takes us and them to an entirely other level. So here on the second simulation, when students have gotten to this point, they should already understand that sample size matters, but that also, as in a political poll, the larger the sample, the more the cost. Likewise, in the real world, we might be able to run only one experimental trial. Replications cost too. In this simulation, however, we can run many trials, and cheap. Here, the top panel shows a distribution of measures from a sample, just as before. So students are familiar with that, but you have to point it out. Notice on the top, it's just what you were doing before. But the bottom shows a distribution of sample means from 500 trials. You can't do this in real life. So this is called the sampling distribution, which is very confusing for students for a while. So it helps to distinguish between the distribution of measures in a sample, one trial, and the distribution of means from many trials. But the real discovery is that the sampling distribution tends towards normal. This is the central limit theorem. As a result, students should see that. Therefore, it is possible to estimate standard error of the mean and confidence intervals. This understood, statistics makes sense and is no longer merely magical. Of course, this will all make far more sense for you when you have tried it yourself. By the way, a clear explanation of the sampling distribution is given by Trokem, and I'll provide that link here, and I'll also provide a link to the central limit theorem. So, returning from a very gently guided inquiry or investigation about the sampling and normal distribution resources, I hope you had some time to visit them and explore them and post your comments and questions. Let's revisit these claims that we examined earlier. I mean, clearly, this this simulation allows us to do things otherwise not possible in the real world. It does look like a worksheet, and how you implement it as not a mere online worksheet is really a lot to do with how you set it up, the guidance that you give students. In my experience is, I just don't hand it to them. We have a discussion about what the expectations are for them, that it is guidance. In fact, they may have this motif of a worksheet in their head from, your goal is to fill in the blanks and get the answers as quickly as possible so you can get on with things you really want to do. So you have to, set it up as, this is a guided inquiry. If you go through this, what it's going to do is it's going to step you through, the recording of data, the making sense of it, the interpreting it, the forming explanation. And unless you allow that process to work, it will be a mere worksheet. But if you allow that process to work, it will be very successful. And I've used this most recently with a class of graduate students, and from five different native languages. We had Senegal and China and Japan and German and Brazil and I think we had one other country, and then plus the foreign language we call statistics. So so it was a nice diverse group and a lot of fun to do, and we were very successful with that. But I've also used this with high schoolers and even my own daughter, and she did really well with it. So finally, I think a value of using a resource like this is being flexible with it. We saw how it's possible to work at your own pace, to bring in other resources as you need to, and the place this can be done. It doesn't require special facilities that much. It does require internet, of course, and a laptop, but or a Chromebook. So the resources are generally available. So at this point, I could close by offering a playlist of virtual labs at BioInteractive. These resources are always free and often have detailed guidance for instructors. Of course, you can search BioInteractive for a plethora of individual resources and thematic questions as well. So the link to this shown on the screen is also available on the right hand of the link icon here. So for more free resources, connect to the BioInteractive site. If you register there, you can keep collections, make your own playlists, keep your own groups, very nice. Join the Facebook group and Twitter. I'll see you there. And finally, I want to thank Jennifer, Melissa, and Amy at HHMI and Maddie at OLC for the opportunity to give this and share this information with you. And thank you for coming. I do look forward to your comments.